All right, welcome back everyone for another deep dive. Today we're going to be talking about something that's been making headlines recently.
Yeah,
Google's brand new quantum chip Willow.
that's right.
And, we've probably all seen these articles floating around about how it's doing these crazy things.
hmm
That would take classical supercomputers billions of years to do.
It's pretty wild.
It is wild. But the really crazy thing is that some people are saying that this is evidence
Oh, yeah.
of parallel universes.
Multiverse, here we come.
Exactly. And so we've got a ton of articles and research to dig into today. So let's see if we can untangle it all.
Well, what I find particularly fascinating is that we're talking about a physical object.
Yeah.
Like, we have this chip. It's not just a theory.
Right.
It's producing results that are so advanced that it's kind of making us question what we thought we knew about reality.
Absolutely. And I think that's what really draws people in.
Right.
It's not just some abstract idea. It's an actual piece of technology that's forcing us to think about these mind-blowing possibilities.
Sure.
So let's start with the basics.
Okay.
What exactly did this Willow chip do that's got everyone so excited?
So they set Willow to work on a problem called random circuit sampling.
Okay.
And it's basically a benchmark problem that's specifically designed to show off what quantum computers can do.
Okay.
And get this, Willow managed to solve it in under 5 minutes.
5 minutes.
5 minutes. Now, compare that to how long it would take the most powerful supercomputer in the world to do the same thing. 10 septillion years.
Okay, I've heard that number being thrown around.
Yeah.
But it's so hard to even imagine 10 septillion years. Like, that's longer than the universe has existed.
It is.
That speed difference is just, it's astronomical.
Astronomical is a good word.
And it really shows you how different quantum computing is from anything we've ever seen before.
Yeah, it's a completely different way of thinking about computation.
Totally.
And this is what's really fueled the debate about whether Willow might be tapping into something outside of our universe.
Okay, so I am struggling to understand how a faster chip means that there might be multiple universes.
Yeah, that's a big jump.
Help me out here.
So the link comes from how the results have been interpreted by Hartmut Neven, who's the founder of Google Quantum AI.
Okay.
And he's suggesting that how well Willow is performing could be evidence of quantum computation happening across multiple parallel universes.
Wait, so are we saying that this chip is making new universes?
It kind of sounds like science fiction, right?
It does.
But Neven's claims are based on the work of physicist David Deutsch and his multiverse interpretation of quantum mechanics.
Okay, so remind me about Deutsch's theory.
Yeah.
How does that all fit in here?
Okay, so essentially what Deutsch is proposing is that every time a quantum event happens,
Okay.
like let's say a particle changes its state,
Mm-hmm.
the universe splits and it creates a new reality for every single possible outcome.
So like a tree branching out.
Yeah, exactly.
With each branch being a different universe.
That's the idea.
So every single quantum event creates a new reality. That's a lot of universes.
Yeah, it's a mind-boggling number.
Yeah.
But Deutsch believes that quantum computers, like Willow, can actually make use of this whole network of universes
Okay.
to do calculations.
So they're not just limited to our universe.
Right, in a sense, they have access to way more computing power than we could ever imagine.
So Willow could be accessing these other realities to kind of boost its processing power.
Yeah, that's the theory.
Okay, it's a wild concept.
It is wild. And to be fair, not everyone's convinced.
Right.
There are plenty of scientists who say that we can explain Willow's achievements without bringing parallel universes into it.
Yeah.
One of the most prominent skeptics is astrophysicist Ethan Siegel.
Okay, and what does Siegel say? If it's not parallel universes, how does he explain this incredible speed?
Well, Siegel argues that we don't need to look beyond our own universe.
Okay.
He thinks the results can be explained by the math
Oh,
of quantum mechanics itself.
so it's not that Willow's accessing other universes.
Right.
It's that it's using the weirdness of quantum mechanics in our own reality.
Exactly. He sees it as people mixing up the math with actual physical universes.
It's like saying the map is the same as the actual place.
That's a good way to put it, yeah. And Siegel's not alone.
Okay.
Other scientists have pointed out that this whole random circuit sampling thing, while it's impressive, it doesn't really have any practical use yet.
It's more of a proof of concept.
Yeah, exactly. And there are even some who say that maybe with enough time and resources, regular computers could do what Willow does.
Okay, so we've got this amazing quantum leap forward with Willow
Mm-hmm.
and two totally different ways of looking at what it means.
Yeah.
Sounds like this debate's not going away anytime soon.
Not at all. It's important to remember that we're still in the very early days of quantum computing.
Yeah.
We're really just starting to understand what's possible.
Which makes it all the more exciting.
Absolutely. But even if we put the whole multiverse thing aside for now, there's a really important question here. What does Willow actually tell us about the future of quantum computing?
That's a great point. Whether it's parallel universes or not, this is clearly a huge step.
Yeah.
What are the big advancements that make Willow so significant?
Well, one of the most notable things is the progress in error reduction.
Okay.
Quantum computers are really prone to errors,
Right.
but Willow's design seems to be much better at dealing with that.
So not just faster, but also more reliable.
Exactly. And that, combined with all the processing power we've been talking about, opens up a whole world of possibilities.
Okay, so we're not just talking about theoretical debates here.
Nah.
There are real-world implications, right? What kind of problems could a quantum computer like Willow help us solve?
Well, possibilities are huge. We're talking about potential breakthroughs in things like cryptography, material science, drug discovery, even artificial intelligence.
So this could change everything, from how we keep our data safe to how we develop new medicines.
It really could. And these are just the things we can think of now. As quantum computing keeps evolving, who knows what else we'll be able to do?
That's what's so mind-blowing about it all.
Yeah.
It's not just about making things a little bit better. It's about changing what's possible.
Right?
It's about unlocking things we can barely even imagine right now.
Exactly. And I think that's the key takeaway here. Willow, with all its amazing capabilities and all these questions it raises, it's a symbol of just how far we've come in our quest to understand and harness the power of the quantum world.
And a glimpse into a future that's full of incredible possibilities. But before we get too carried away,
Right.
I think it's time to dig a little deeper into Willow's technical achievements.
Absolutely. Let's take a closer look at what makes this chip so special
Yes,
and how it's pushing the boundaries of quantum computing.
let's do it. Okay, so we've established that Willow is a pretty big deal,
Definitely.
but I'm still a little fuzzy on the details.
Yes.
What makes it so much more powerful than a regular computer? What's going on under the hood?
Well, at its core, Willow uses the principles of quantum mechanics, which govern how particles behave at the atomic and subatomic level.
Okay.
And unlike classical computers, which use bits, zeros and ones,
Right.
quantum computers use these things called qubits.
Okay, I've heard of qubits,
Yeah,
but I'm not really sure I get the difference.
sure.
It just sounds like a fancy name for a bit.
Well, it's more than just a fancy name.
Okay.
Qubits have this special ability
Okay.
that bits don't. It's called superposition.
Superposition. I feel like I've heard that before.
Yeah, it's a mind-bending concept.
That remind me.
Okay, so imagine a coin spinning in the air.
Oh,
Before it lands, it's both heads and tails at the same time, right? That's kind of like superposition.
Okay.
A qubit can be both 0 and 1 at the same time, like it holds both possibilities.
So it's not either.
Right.
It's both at the same time.
Exactly.
That's pretty weird.
It is. It's one of the strange things about quantum mechanics, but how does that translate into more power?
Yeah, how does that help?
Well, think of it this way. If you have one qubit, it can explore 2 possibilities at the same time.
Okay.
2 qubits can explore 4 possibilities.
Okay.
3 qubits, 8 possibilities, and so on.
Okay.
So it grows exponentially, meaning that a quantum computer with even just a few hundred qubits can explore more possibilities than there are atoms in the entire observable universe.
Wow. Okay, that's a lot.
It is.
That puts it into perspective.
Yeah, it's mind-boggling.
So the computing power just explodes.
It does, but there's a catch.
Okay, there's always a catch.
One of the biggest challenges with quantum computers is that they are super sensitive to errors.
Right. I remember reading about that.
Yeah, they're very delicate systems.
Yeah.
So how does Willow deal with that?
Yeah. How do they fix that?
Well, Willow uses a special technique called surface code error correction.
Surface code. Okay, break that down for me.
All right, so imagine you have a really important piece of information written on a single piece of paper.
Okay.
It's pretty vulnerable, right?
Yeah, you could spill coffee on it.
Exactly.
Yeah.
But now imagine that you write that same information on multiple pieces of paper,
Okay.
with each copy slightly different.
Mm-hmm.
Now, if one copy gets damaged, you can still figure out what the information was.
Oh, like a backup system.
Exactly. It's like having multiple backups.
Okay.
Surface code does something similar.
Okay.
It spreads the quantum information across multiple physical qubits.
Okay.
So even if one qubit has an error, you can still get the right answer.
That's pretty clever.
It is. It's a very ingenious way to make the system more robust.
So Willow can harness the power of superposition,
Yes.
but it also has this built-in error correction system.
That's right.
Okay, no wonder it's getting such incredible results.
It's a powerful combination.
But I'm curious,
Yeah.
beyond the theory, what does this kind of power actually look like in practice?
Well, let's think back to that random circuit sampling problem that Willow solved. It's like having a circuit with all these random gates that flip qubits between 0 and 1.
Okay.
The task is to sample the output of this circuit, which is essentially a string of zeros and ones.
Great.
Sounds simple enough?
Yeah.
But as you add more qubits and more gates,
Yeah.
the number of possible outputs just explodes.
So it becomes really hard for a classical computer to figure out all the possible outcomes.
Exactly. It's like trying to find a specific grain of sand on a beach the size of the Earth.
Okay, so basically impossible.
Pretty much. Yeah.
But Willow can do it.
Willow can navigate this massive space of possibilities,
Mm.
and it can do it incredibly efficiently.
And how does it do that?
Well, this is where entanglement comes into play.
Entanglement. Okay, another one of those quantum terms.
Yeah, it's a weird one.
I need a little help with that one.
So imagine two qubits that are linked.
Okay.
Even if they're physically far apart, they're still connected in a way. If you know the state of one qubit,
Yeah.
you instantly know the state of the other one, no matter how far away they are.
So it's like they're communicating faster than the speed of light.
Not exactly communication.
Okay.
It's more like they share a connection that goes beyond distance.
That's pretty wild.
It is. It's one of the things that makes quantum mechanics so fascinating.
Okay, so using entanglement and superposition,
Hmm.
Willow can essentially do calculations across this huge interconnected network of qubits.
Exactly.
Okay, so we've got superposition, entanglement, and error correction.
All working together.
Yeah, all working together to create this super powerful computing system.
That's the idea.
It's starting to make more sense.
Good. I'm glad.
But I'm still trying to grasp the practical implications.
Yeah.
What kind of real-world problems could we actually solve with this technology?
Well, let's start with cryptography.
Okay.
A lot of our current encryption methods rely on the fact that it's really hard to factor large numbers.
Right. It would take a regular computer forever.
Exactly. But quantum computers, with their ability to perform calculations on a completely different scale, could potentially crack those codes.
Oh, so our current ways of keeping data safe could become obsolete.
It's a possibility, which is why researchers are already working on new quantum-resistant cryptography methods.
Oh, good to know.
Yeah, we need to stay ahead of the curve.
Okay, what about other applications? What about those breakthroughs in materials science and drug discovery we talked about earlier?
Well, quantum computers could really change those fields
Okay.
by allowing us to simulate how molecules and atoms behave with incredible accuracy.
So instead of doing experiments in a lab,
Yeah,
we could use a quantum computer to see how different molecules interact.
exactly. It's like having a virtual lab inside a computer.
Okay.
And this could lead to all sorts of amazing new materials.
Like what?
Think about materials that are super strong but incredibly light,
Okay.
or materials that can conduct electricity without any loss of energy.
Wow, that's pretty futuristic.
It is. We're talking about stuff that sounds like science fiction.
And in drug discovery.
Well, quantum simulations could help us design and test new drugs much faster,
Okay.
potentially finding cures for diseases that we can't treat today.
That's amazing.
It is. It's a really exciting prospect.
It sounds like quantum computing could have a huge impact on so many different areas of our lives.
It really could, but of course there are also challenges.
Right, because there always are.
Quantum computing is still in its early stages.
Yeah.
There are still a lot of technical hurdles to overcome.
Okay.
And we also need to think carefully about the ethical implications of this technology.
Okay, like what kind of ethical implications?
Well, one concern is that it could lead to job losses.
Whoa, right.
If quantum computers become powerful enough to automate tasks that currently require human expertise,
Yeah,
that could have a big impact on the workforce.
that's definitely something to think about. What about the possibility of misuse? Could this technology fall into the wrong hands?
That's a valid concern. The power of quantum computing could be used for harmful purposes,
Right.
like breaking into secure systems or developing new weapons.
So we need to be careful.
Absolutely. We need to have open and honest discussions about the potential impact of this technology,
Yeah.
and we need to establish ethical guidelines
Yeah.
to ensure that it's used responsibly.
So while there's a lot of excitement about the potential benefits,
Yeah.
we need to be aware of the risks as well.
We can't just focus on the science. We need to consider the societal
Right.
implications.
It's not just about building cool gadgets. It's about using them for good.
Exactly.
Well, I think we've covered a lot of ground here,
We have.
from the really mind-bending principles of quantum mechanics to the potential benefits and risks of this technology.
Yeah, it's been a fascinating discussion.
And I think this leads us to a really crucial point. The fact that we're even having this debate about Willow
Hmm.
and whether it can access parallel universes
Yeah,
shows just how far we've come.
it really does.
Our technology is pushing us to confront some of the biggest mysteries of the universe.
It's like we're entering a new era of exploration.
Yeah, where science fiction and reality are starting to blur together.
Exactly. And while we might not have all the answers right now,
Yeah.
it's the pursuit of those answers that makes this so exciting.
It's the unknown that drives us forward.
It does.
And speaking of the unknown,
Uh-huh.
there's another aspect of Willow that I find particularly fascinating.
What's that?
Its potential to help us understand the nature of reality itself.
Okay, now you've got my attention. How does a quantum chip connect to something as big as the nature of reality?
Well, one of the weirdest things about quantum mechanics is the idea that observation actually plays a role in shaping reality.
So you're saying that by looking at something, we change it?
In a way, yes. At the quantum level, particles don't really have definite properties until they're observed.
Okay.
It's only when we measure them that they become real, in a sense.
That's so counterintuitive. It suggests that our consciousness, the act of observing something, has a direct impact on the physical world.
Exactly, and that raises some really big questions.
Like what?
Is reality objective and out there, regardless of whether we're looking at it?
Yeah,
Or is it somehow shaped by our awareness?
those are some deep philosophical questions.
They are. And it sounds like Willow, with its ability to delve into the quantum world, could actually provide some clues.
It's possible.
So Willow isn't just a powerful tool for computation.
Right.
It's also a tool for exploring the very nature of existence.
Exactly. And that's one of the things that makes this whole field so exciting.
Mm-hmm.
It's not just about building better machines. It's about understanding the universe and our place in it.
That's a really beautiful way to put it.
Thanks.
It seems like Willow and quantum computing as a whole
Yeah.
is pushing us to ask some of the most fundamental questions that humans have ever grappled with.
It is. And while we may not have all the answers right now, the journey itself is what's important.
And I can't wait to see where it leads us.
Me neither. But before we get too lost in the big philosophical questions,
Okay.
let's take a step back
Mm.
and recap the key takeaways from our deep dive into Willow's technical achievements.
Sounds good.
Hmm.
What are the main points you think our listeners should walk away with?
Well, first and foremost, Willow is a major leap forward in quantum computing.
Mhm.
It's a real demonstration of the incredible potential of qubits,
Okay.
superposition, entanglement, and error correction.
It's not just hype.
Yeah.
There are real, tangible advancements that are pushing the limits of what's possible.
Absolutely. And while the debate about parallel universes is intriguing,
Right.
it's important to remember that we can understand what Willow is doing
Yeah.
within our current understanding of quantum mechanics.
It's a good reminder that we don't always need to come up with these exotic ideas
Yeah.
to explain the amazing things happening in science.
Sometimes the explanation is right there in the laws of physics.
Exactly. And finally, I think it's crucial to emphasize that while quantum computing is still in its early stages, it has the potential to completely revolutionize so many aspects of our lives.
Absolutely.
From how we protect our data
Right.
to how we develop new materials and medicines.
It's a field that's full of possibilities.
Yeah, and it's one that I'm really excited to keep exploring.
Me too. I think the most important takeaway for our listener is this. Stay curious,
Yeah.
keep asking questions, and never stop exploring the wonders of the quantum world.
Because who knows? The next
Yes.
big discovery might be right around the corner.
It might, and it could change our understanding of reality forever.
It's really hit me as we've been talking about Willow,
Yeah.
that this isn't just about some new technology.
Right.
It's really a fundamental change in how we understand
Wow.
and interact with the world around us.
I totally agree. Quantum computing really challenges our everyday intuitions about how things work.
Yeah.
It forces us to confront the limits of what we thought we knew
Hmm.
and to be open to the possibility that reality might be even stranger than we ever imagined.
It's like we're being asked to step outside our comfort zone,
Yeah.
our kind of neat and tidy view of the universe,
Right.
and embrace a reality that's fundamentally unpredictable and interconnected.
Exactly. And I think this shift in perspective could have a huge impact, not just on science and technology, but on how we approach everything.
Wow.
Our lives, relationships, our understanding of our place in the universe.
That's a profound thought.
It is.
So it's not just about building faster computers.
No.
It's about expanding our consciousness, opening ourselves up to new ways of seeing
Right.
and experiencing the world.
Exactly. And who knows, maybe this quantum revolution will lead to a more interconnected view of reality.
Okay.
One that recognizes the deep interconnectedness of everything.
That's a beautiful idea.
Yeah.
But let's bring it back to Willow for a second.
Sure.
What's next for it? What are the challenges that researchers are still working on?
Well, one of the biggest challenges is scalability.
Okay.
Willow's 70 qubits is impressive,
Yeah.
but we need to build systems with thousands or even millions of qubits
Wow.
to really tackle some of the more complex problems out there.
So it's not just about making individual qubits better.
Right.
It's about connecting lots of them together in a way that's stable and reliable.
Exactly. And that's not easy.
Yeah, I can imagine.
Keeping these quantum states stable, especially as the system gets bigger, it's a huge challenge.
What about the software side of things?
Yeah.
Do we need to come up with totally new programming languages and algorithms to really use these quantum computers?
Absolutely. Quantum algorithms work completely differently from classical algorithms.
Okay.
They take advantage of these special properties of qubits to do calculations in ways that classical computers just can't.
So you can't just take your old code and run it on a quantum computer?
No, it doesn't work that way.
Okay.
We need entirely new ways of thinking about problem solving.
That sounds like a pretty exciting challenge for programmers.
It is. It's a whole new frontier.
So we've got the hardware challenges,
Yes.
scalability, stability, and then the software challenges.
Right.
Developing these new algorithms.
Exactly. What about the applications themselves?
Yeah.
Where do you see quantum computing having the biggest impact in the near future?
You know, I think one of the most promising areas is materials science.
I agree.
That ability to simulate molecules and atoms at a quantum level could completely transform how we design new materials.
It could. We could create materials with properties that we haven't even thought of yet.
Like what? Give me an example.
Imagine materials that are lighter than air but stronger than steel.
Wow.
Or materials that conduct electricity with no resistance at all.
That's mind-blowing.
It is. The possibilities are endless.
What about drug discovery?
Yes.
You mentioned earlier that quantum computers could really speed up the process of finding new cures.
That's right.
How would that work?
Well, quantum simulations could help us understand how drugs interact with the body at a molecular level.
Okay.
So we could develop much more targeted and effective treatments.
So we could potentially create personalized medicine
Yes.
tailored to an individual's genetic makeup.
Exactly. And we could test new drugs virtually.
Okay.
So we wouldn't need these lengthy and expensive clinical trials.
That would completely revolutionize healthcare.
It would.
But it's not just about the practical applications, is it?
No.
There's also this potential for quantum computing to help us understand the universe itself.
Absolutely. Quantum computers could help us unlock the secrets of dark matter.
Okay.
Black holes, the Big Bang.
Wow.
We could learn things that have been hidden from us for centuries.
It's amazing to think that something that came from studying the tiniest particles
Right.
could have such a huge impact on our understanding of the cosmos.
It really highlights how everything is connected.
Yeah.
From the smallest to the largest scales.
I think we've covered so much ground today.
We have
From these mind-bending ideas of quantum mechanics to the potential benefits and challenges of this technology.
It's been a great discussion.
I hope our listeners have really gained a deeper appreciation for the power and potential of quantum computing.
It's a fascinating field.
I know I have.
Good.
It's been an incredible journey.
It has.
But before we wrap up,
Okay.
I want to leave our listeners with one final thought.
I'm listening.
As we go deeper into this quantum realm, we're not just discovering new technologies.
Right.
We're discovering new ways of thinking,
Yeah.
new ways of seeing the world, and new possibilities for what it means to be human.
That's a great way to put it.
And I think that's really the most exciting part of all of this.
I agree. It's not just about science.
Yeah.
It's about expanding our consciousness and understanding our place in the universe.
Well said. So to our listeners out there,
Yes.
stay curious, keep exploring,
Yeah.
and never stop asking questions.
The future is full of possibilities.
It is. The future of quantum computing is incredibly exciting, and we can't wait to see what happens next.
Who knows, maybe we'll even unlock the secrets of those parallel universes
Yeah.
and discover that reality is even more amazing than we ever thought possible.
That's it for our deep dive today.
Thanks for listening.
Thank you all for joining us on this incredible journey into the world of quantum computing.
It's been a pleasure.
Until next time, keep diving deep.